I took the middle term, I divided by 2. That gave me a fraction, so I left it as a fraction. Squared my fraction to get 25/4. So I'm going to add that to both sides. 25/4 plus 25/4. My problem now, which is about to become your problem, is that I have a whole number plus a fraction, and you have to get a common denominator and all that craziness. All right, so -1 is a whole number. Let's say it's been 1,000,000 years since you've done this. It happens, right? Make that whole number a fraction. We've talked about that. Put a 1 on the bottom of it. When you make an equivalent fraction, I need a 4 in the denominator, so multiply the bottom by 4. But you have to also do the top. So I have -4/4 plus my 25/4, which is 21/4. Don't ever make it a decimal or a mixed number. Those days are gone. 21/4. Looks gross, feels gross, but it's the same steps. We added to both sides. It's just I had to change this whole number to a fraction, and it's the fraction -4/4. You have to get the same denominator. Don't add the denominator, keep the denominator. You're just adding the numerator. Okay, I'm trusting my steps. Don't do anything different just because it looks gross. Put your parentheses down, put your square down, put your x down. And the rule is the same as it's been. What's going to go in parentheses there? -5/2. Whatever you got when you took half, that's what's going right there. -5/2. And then move that 21/4 over. I had y plus 21/4, so I have to subtract 21/4. Make sure you do that to both sides. So my vertex is 5/2 and -21/4. It was positive 21/4 is over here, and you have to move it over. So you have to do subtract 21/4 from both sides. No? It got messy. So over here what we had is we have y plus 21/4 equals x minus 5/2 squared. And then we had to get rid of that -21/4, so we had to do that to both sides. So that's how we ended up with that negative. The 5/2 is positive because we always go the opposite direction there when we graph. You know, none of you are helping me remember to record. You have no one to blame but yourself. I don't need you. I remembered on my own. Move that 3 over. Okay, so normally we take half of that 8 and then we square it. Is there a B or something? What do we got?
Keeps touching me. It's a fly.
Oh, that's creepy. It's one of those late fall flies, so they're really slow, you know, because they're about to die and they get all weird. Like they'll stare at you. I hate that. So we can't just do our normal things where we take half of that because this is a little problem. We have to factor that out. We're going to factor that out. And it looks like this. Nothing is happening over there on the left. It's just hanging out. But we're going to factor a 2 out, which means divide both of those by 2. You get x squared plus 4x. I want you to leave a gap and then close your parentheses like that. Leave room because you're going to fill this in with a number, just like you have before. We just have to do some different work, okay? So we're going to ignore this 2 on the outside right now. We still want this to be a perfect square. We want this to factor nice as x plus something squared. So we know how to do that. Now go ahead and take half of your middle term and square it. So now we're going to go off to the side and do our little positive 4 divided by 2 is 2. And when we square 2, we get 4. And we're going to add that right here. So we've created a perfect square. Here's our problem. Normally, when we added something here, we added the same thing there. Because before, if we had increased the right side by 4, we had to increase the left side by 4. But we did not increase the right side by 4. You see why? So what did we increase the right side by? 8, yeah. This 2 in front is actually being multiplied by everybody inside. So when you wrote plus 4, you actually increased the right side by 2 times 4, which is 8. You actually increased the right side by 8. So you have to add 8 to the left side.
Wait, say that again?
So because of this 2 right here, this forces us to multiply everything in the parentheses by 2. So when we wrote down plus 4, on the right side of the equal sign, I really added positive 8 to what was already there. Because this really is 2x squared plus 8x plus 8. Yeah. So I had the 2x squared plus the 8x. I really added plus 8. Now, if your notes look like that, you're not going to have any idea where this came from later on. So write yourself a note, you know? Because you know how it is. You look at this, especially this is Thursday. You're not going to look at this till Monday night. You'll say, what the heck is that? You know? I don't know if my dog's going to vomit on a video between now and then. Hopefully not. But one of them, for one class, had a mouse run out. That was an adventure. Okay, so everybody gets what's happening here, all right? So now you're going to continue with the problem. So I have y plus 11 equals, now the 2 is still going to sit there, but I am going to factor that trinomial. It's x plus 2 squared. Remember, if I multiplied x plus 2 times itself, I would get x squared plus 4x plus 4. I'm leaving that 2 on the outside. Now move your 11, and you're done. Minus 11. Now that shouldn't look unusual. You graphed some. I don't know if you had any. You didn't have any on your test where you had to do wide or narrow, did you? You know what else I forgot? All that domain and range business with the, if it's in a fraction, remember we had to set it equal to, I forgot to put all those on the test. You felt cheated, I feel sure. You know? Also, I ate combos yesterday, and I thought of you all. But I didn't bring any. Again today. Minus 11 from both sides. Now this does not affect your vertex, just like when you graphed them, you graphed some that looked just like this for homework or for in-class work, and all that 2 did is make it narrow. But it did not affect your shift. Your shift would still be over to -2 and down in 11. So that's still your vertex. -2, -11. All right, let's review that one, because that one is a little funky.